There is a specific moment most of us remember a little too well. The night someone you loved looked at you and said they were done. The message that never got a reply. The argument that ended something you thought would last forever. Or maybe it was not romantic at all. Maybe it was a room full of people laughing at something you said, a mistake you made in front of everyone, a betrayal from someone you trusted. Whatever it was, it left a mark, and years later, you still flinch when something reminds you of it. You've tried to move on. You've told yourself it doesn't matter anymore. But the memory doesn't care what you tell it. It just sits there, sharp and ready, waiting to surface at the worst possible moment. Now imagine this. What if you could go into a clinic, lie down for 20 minutes, and walk out with that memory softened or gone entirely? What if heartbreak, humiliation, trauma, every moment you wish you could forget, could actually be erased, not with time, but with technology? This is not science fiction. It's happening. And soon, forgetting might not be something that just happens to you. It might be something you choose. Before you can delete a memory, you have to understand what a memory actually is. And here's the thing. It's not a photograph tucked away in a filing cabinet somewhere in your brain. It's more like a song. Every time you remember something, your brain has to replay it, reconstruct it from scattered pieces stored across different regions. Some parts live in your hippocampus, the brain's memory organizer. Other pieces are in your amygdala, which tags memories with emotion, fear, joy, pain. The sensory details, like the smell of rain or the sound of someone's voice, get stored elsewhere. When you recall that painful moment, your brain pulls all those fragments together and plays them back. And here's the crucial part. Every time you remember something, you're not just accessing it, you're rewriting it. Neuroscientists call this reconsolidation. The act of remembering makes a memory temporarily unstable, vulnerable, like a file that has been opened for editing. For a brief window, minutes to hours, that memory can be altered, weakened, or even erased. If you can intervene during that window, you can change what gets saved back into long-term storage. You can rewrite the past, not by changing what happened, but by changing what your brain keeps. The first real breakthrough came from a lab studying fear. Scientists trained rats to associate a sound with a mild shock. Every time the rats heard the sound, they froze in terror. Classic fear conditioning. But then researchers gave the rats a drug called propranolol right after triggering the memory, right during that reconsolidation window when the memory was vulnerable. The next day, the rats heard the sound again, and they didn't freeze. The fear was gone. The memory of the shock still existed, but the emotional weight had been stripped away. The trauma had been defanged. This was not temporary. It was not suppression. The fear memory had been chemically edited out of existence. Then they tried it in humans. In 2007, researchers in the Netherlands gave propranolol to people living with trauma, soldiers, assault survivors, people haunted by memories they could not escape. They asked them to recall their trauma in detail, triggering reconsolidation, and then administered the drug. When they tested them weeks later, the participants could still remember what happened, but the memory no longer triggered panic attacks, flashbacks, or nightmares. The physiological terror response was gone. One participant described it like this: "I remember it happened, but it feels like I'm reading about someone else's life." That's selective amnesia at the chemical level. But propranolol is just the beginning. The next generation of memory manipulation doesn't rely on drugs at all. It uses light. Optogenetics is a technique where scientists genetically modify neurons to respond to light. They can literally turn specific brain cells on or off with a laser. In 2014, researchers at MIT used this to locate the exact neurons that stored a fear memory in a mouse's brain. Then they activated those neurons with light while simultaneously triggering a pleasant experience, something the mouse enjoyed. The result? The fear memory was overwritten. The mouse no longer associated the original stimulus with fear. It had been replaced, reprogrammed, like editing a line of code. The implications are staggering. If you can tag a memory, you can theoretically rewrite it. You could take the memory of your ex and pair it with something neutral or even pleasant. You could uncouple the image of a traumatic event from the feeling of terror. You're not losing the memory, you're changing its emotional meaning. And then there's the hardware approach. Neuralink and similar brain-computer interface companies are developing chips that can read and write neural signals in real time. These are not hypothetical. They've already been implanted in humans for medical purposes, helping paralyzed patients control computers with their thoughts, restoring limited vision to the blind. But if a chip can read your brain activity, it can theoretically identify the neural signature of a specific memory. And if it can identify it, it can disrupt it. It can stop you from ever recalling it again. Memory deletion wouldn't require surgery every time. It could be an app. Press a button, recall the memory, let the chip interfere with reconsolidation, and the emotional charge fades. You keep the facts, lose the feeling. The scar remains, but the wound closes. But here's where it gets complicated. If you can erase pain, you can erase anything, and not all painful memories should be forgotten. Some of them teach us, some of them define us. If you delete the memory of a toxic relationship, do you lose the lesson that taught you what red flags look like? If you erase the humiliation of a public failure, do you lose the humility that made you better? There's a reason trauma survivors often say their worst experience also shaped who they became. Memory is not just storage, it's identity. And if you start editing out the uncomfortable parts, what's left? And then there's the security problem. If your memories can be rewritten, who controls the rewrite? In a world where memory chips exist, could someone else edit your past without your knowledge? Could an abuser make you forget what they did? Your memory of events is the only proof you have that they happened. If that proof can be deleted, truth itself becomes negotiable. And finally, there's the emotional cost. Pain is terrible, but it's also proof that something mattered. The reason heartbreak hurts so much is because love was real. The reason betrayal stings is because trust existed. If you delete the pain, do you also delete the meaning? If nothing ever hurts, does anything ever matter? The direction is set. From propranolol trials to optogenetics to brain chips, we're closing in on the ability to edit memory like a document. The question is not whether this technology will exist. The question is what we do when it becomes as accessible as therapy. Would you delete your worst memory if you could? And if you did, would you still be you? Or would you be someone else, someone who lived a slightly different life, one edited frame at a time? Maybe forgetting is not the escape we think it is. Maybe remembering, even the painful parts, is what makes us human. Or maybe that's just what people say when they don't have a choice. Soon, we will.